This pneumatic palm beveler is great for chamfering parts. We do a lot of water jet blanks, and it's great for second operations like this. The inserts last a long time on steel and aluminum. Just keep in mind you're going to go through inserts if you start chamfering stainless. A bearing tool can be used to align your parts. Just don't over tighten the clamp and it'll move as it needs to and align everything as you see here. I tried using a router bit as a form tool, and as you can see, it worked. Why, you ask? The same reason we jumped off high places with garbage bags as kids, to see what would happen. This one's pretty cool. I placed an inner tube inside the part, and it took care of the chatter. An indicator could be placed on the face to make sure that the part's not distorted while inflating. This electronic level is great for setting up parts like you see here. We tested the accuracy of this level on one of our C-axis lathes, and it's a lot more accurate than you might think. Did you know the tips of your indicator can be replaced? We put this button style insert in, and as you can see, it skips right over these rough serrations. If you're tired of your clamps falling down, a bit of scrap tubing can be used like a spring, or you could just use a spring. The table's in pretty rough shape on this 1960 Bridgeport, but it wasn't me, I swear. If you've ever struggled to hold on to thread wires, there's a trick for that. Just go grab some of your kids' Play-Doh. One of the best threading tips I can share is to try adding spring passes throughout the cycle. While it adds a bit of time, it reduces the amount of burst created and creates a better thread overall. This is great for low volume work. There are a lot of ways to set up a boring bar, but one way is to scribe a line with a tool that's already known to be on center and align the tip as you see here. The knock test is one of the best ways of determining how a tool is going to behave in the cut. If the turret is aligned properly and the boring bar has reference flats, you should just be able to use a square to set up your boring bar. You could also use an indicator to make sure that the bar is parallel with the machine's axis, like you see here. If you've done everything correctly, you should be able to attain finishes like you see here, and if you're still struggling, feel free to reach out. Squares can be combined to quickly check your setup. I couldn't leave this one out. I had to show off a little bit. Setting up a boring bar to do a pipe coat. Depending on your comfort level, it could be faster to do something like this on a CNC machine or to do it manually. Comment below if you think manual machining still has a place in manufacturing. This tool is called a lathe spider. What you have are adjustable legs that compensate when the chuck is tightened, allowing you to machine your soft jaws. We'll cover a couple more tricks for internal clamping in the next video. This is more of a mechanic's tool, but sure makes working on this old South Bend lathe a lot easier. This is one way to use that pointed edge finder that comes in most of the kits. We're going to turn the tool on just like we would if we were going to edge find, but it allows us to go up against a tapered surface and better visualize where the center of our scribed line is. Another use is aligning the tool like you see here by feeling for mismatch between the shank and the movable portion. You should be able to feel less than a thousandths mismatch, but unless you have machine chamfers, it's not the most accurate. You might be familiar with the hole saw inside a hole saw trick, but check out this little plug that was perfect for what we were working on. Marking your jaws at the extent of travel is never a bad idea. A peck drilling cycle can be used for peck turning, as you see here. This material is called UHMW, and it's impossible to break a chip through conventional means. I call this one the bag nit, and you could use it for dredging your coolant tank among a lot of other things. Milling creates small chips. Milling a groove in the OD creates an interrupted cut for the turning profile to create short chips. Pulling the chips away from the chuck is always a good idea with plastic. Reversing the drill removes the chips. They go out the way they come on. Parting off with a peck. Every peck breaks that chip. Bar pull. Rinse and repeat. Milling a slot creates an interrupted cut. Each time the tool comes around to that groove, the chip is broken. Visualizing boring bar clearance. An easy way to dial in a vise on an angle. This old Starrett protractor is one of my favorite tools. As you can see here, it slides right under the vise and is super convenient. It's harder to find a good automatic center punch these days, but if you come across one, it's a great tool to have in your box. Tape can be used like a spindle liner to take up the space between the workpiece and the spindle bore. Stock should never be left unsupported like you see here. Always secure it, please. Splitting a piece of round in half creates one of the best compensating setups you'll ever see. This wrench is both round and tapered, and as you can see, it's held very securely. If you enjoyed this video, please like, share, and subscribe. It means a lot. Thank you.